Hello, welcome back and welcome to session 2 on the topic Smart Solutions for Industry 4.0. This session is chaired by Christine Neuy. She's Managing Director at microTEC Südwest and the chairwoman of this afternoon session. Thank you, Christine. Christine will take over the moderation in the questions and answers panel at the end of the session. You can already start writing your questions to the speakers using the chat window or the questions feature. Our first presentation in this session comes from Alessandro Marini. He is a senior advisor at Associazione Fabbrica Intelligente Lombardia, AFIL in Italy. You have the floor, Mr. Marini.
Thank you very much. Welcome to everybody. Thank you for being here for this keynote that I hope to share some comments with you. I have to start. Yeah, now you can see my video. Yeah. So what is AFIL, first of all? I cannot go ahead with the, yeah, okay. AFIL is the Lombardy Intelligent Factory Association and is only a few words, the counterpart of the Lombardy region for making industrial policy in advanced manufacturing. So we have a number of companies that work with us and are part of the cluster, and we are discussing this. But the most important thing is that we are very operative on the field, and because we want to be part of the development of the advanced technology for manufacturing. So what we will discuss today is that what's happening with Industry 4.0 than everything that is now happening after we have adopted the digitization paradigm, because this has been a very important driver for the development of the factories in Europe and in the world. But this it's very important. Today we have to begin to think what's happening with all the automation we have introduced, with all the digitization we have introduced in new technology that has something to do with a lot of factors that are now under the development. As for example, also with the COVID-19, there's a lot of things that are on, because what we have done with all the automation is that now we have taken the people, the human, out of the factory. We have dehumanized factory because all the automation, especially in very standardized production, have put a lot of conscience about the safety of the people. So we have a lot of caged factories. We have a lot of robotized factories. We have places where the humans cannot go, and the humans cannot give their humanity into the manufacturing. This is something that I think we are losing something in this process, because for humans being part of the production process means to introduce a lot of skills, lateral thinking, and problem solving, and every day with the high automation that is today in the factories, it's very difficult to do it. The important thing is that what we have to do is that we have to focus on humans, and we have to take care of several aspects that are all fundamental to make efficient the contribution of the humans into the factory. And one of the most important things is wellness, because safety and security are very important. I know very well the chief operating officer of Hitachi Rail Italy that told me that every euro spent in security and safety has been the best investment he has done, because the people working in a safe environment are very more productive, and also all these kind of things support the inclusion of the people into the factory, enablement of people, and increase the flexibility. And which are the major topics that we have to cope with when we think about the factories for humans? There are three major things, in my opinion. The first is wellness and operation support. So how the people have to be into the factory. Second thing is human-machine collaboration. So human-machine automation does not have to be something outside human, but we have to go more into the collaboration with the machines. And the third thing is something that is happening now with the huge amount of digitization we have put into the factory. It is the need of new job profiles and new organization support in the factories. Let's see, beginning with the fact that the operation support. So I call it the problem of the red button. One of the most important things I think we have to take into account when we design new factories is that we have to keep in mind that when we automate a factory, we still have workers that have to be focused on what they are doing. So what they are doing is often something interacting with the machine. They have to know the machine, they have to know the process. So one of the important things is that we have introduced in the last years a lot of screens into the factory, and these screens have to be designed with keeping in mind the fact that the human doesn't have to be there to interact with the screens, but the screen is something that has to help him. So the problem of the red button is, for me, very important to understand, that because the red button is the only one interface that the human has to understand with the machine, but the intelligence, the expertise of the machine is introduced behind the machine. So making a real factory for humans means that we have introduced all the rules to make them working, and the human have only to interact with the red button, and the machine knows what happened taking into account which is the phase of the process. So it's important here that the skill and support for the people is very much focused on the traditional technologies that needs to be interacting with the plant, then to be a digital operators that is able to interact with complex screen. Second thing is operation support. There is, for example, this is a factory, it's a laser machine factory. And I show you because this is a very important experiment that we are doing with one of our members that is doing an important project for managing a complex operation in assembly. This is very advanced. Several techniques are used. We have introduced the process, the concept of micromethods when, for example, the product in production is an active part of the assembly interaction. So the important thing is the operation have a strong interface with where he can find everything and find also the tools to interact with the machine, interact with the instructions, and interact also with the logistics part of the factory. The logistics part, for example, the logistics part of the factory is there is a manned forklifts and transpallet, and all these things are coordinated by a higher intelligence where the man is instructed which material is to be put on a particular place to support the operations, and all the coordination intelligence is able to orchestrate the operation of the factory. Here, the skill of the workers is very high, is very important. They have to be an important part of the process, but still, the important thing is that the technology is something that is very light and helps them to collaborate and coordinate the operation to be more flexible. For example, one of the things that we want to introduce, and it's very important in the future to introduce in the manufacturing operation, are the new technologies, for example, augmented reality or virtual reality, that need to be very accepted by the operators. And these, all this kind of knowledge that we are introducing into the factory is very important, because it can serve not only for the building of the machine, but also for the supporting the machine after it is installed at the client side. So one of the most important projects we are designing at the moment is that we want to introduce an adaptive and incremental training. So using the information and all the things that we have collected to support the operation during the operators during the manufacturing operation can be okay for building, for example, training for new operators, or training for the clients that are using the machine into the client side. They can be trained on how to maintain the machine or repair the machine. So one of the things that we are discovering, that when we are able to create information that are and supports that can help the operators to work, we are also creating a knowledge base that is very important also for the other parts of the delivery process. The collaboration is very important. Collaboration with robots, it means that the robots can help the operators in making better their works, but also helps adaptability, also helps flexibility, and also helps the operators to invent their way to use the robot into the manufacturing process. So what we have is that with these technologies that are already in place, the operator is back in manufacturing process. The most important thing is that we have noticed that we are using technologies that are already on hand. The most important thing is that we have to understand how to use it. So invent the new way of using this. The first topic I want to put there is that there are operation support. Operation support is very important, because today there are two major issues in terms of organization. And the first one is that factories don't work without digital, and the second one is the process is the critical topic. So process design is very important. So, you know, when today the need of operation support is very central. After having automated everything, the factories understood that they have to have someone that guarantees 100% operability of the digital and all the automation and IoT there is on site. So it's important. One of the most important processes that we are seeing into the factory is the birth of these operation support, and that they are able to guarantee security, networking, and availability of the operations. And the second thing is that the process design. Process design that in the past was more or less, okay, so we have been in the world of more or less, so your bill of material was okay, but not so perfect. Maybe the cycle, especially in Italy, routings were not so perfect. Today we cannot do this. With everything has to be perfect. We have to go to the universe of precision, and the process engineers today are the masters of smartness. Process engineers and the importance that process engineering has into the factory today is critical. We call it the cyber physical model, so the ability to put everything into a model from which we are going to deliver all the information to the factory. Finishing, last slide, the most important thing is that we have to keep in mind that the humans are fundamentals for the intelligent factory. So artificial intelligence, in my opinion, doesn't exist. We have very good expert systems. We have very good adaptive system. We have everything, but intelligence is another thing. It's something human. It's something that it belongs to the humans. It's lateral thinking. Is adaptivity. Is the empathy between the humans. And we have to keep in mind that we have to remain focused on the human factor, because we cannot have in the future any intelligent factory if we don't have the humans in the factory. Thank you very much.
Thank you too, Mr. Marini. We now come to Mirko Ross. He's founding partner and CEO of Digital worx, a software company for mobile applications in Germany. Here you are, Mr. Ross.
So hi, thank you very much, and I hope you can see my screen.
We do. Can you also turn on your camera, please?
Pardon?
Could you also turn on your camera,
sorry.
please? Yes. Okay, perfect. Yeah. Thank you.
So thank you very much, and thank you very much for the opportunity to present what we have done in the CISEMA project. So this project is part of a piloting opportunity which has been done in the EU project IoT for Industries, and it's a joint project of Calfas, which is a machine manufacturer, Odins in Spain, which are sensor network company, and my company, Digital worx. We are solution providers for IoT. So just give you an idea of what we are talking about. I mean, mainly, I think if we talk about cybersecurity in the Internet of Things, we mainly think about we can manage the situation like this. So we are just building our firewalls, and some zombie hijacked network devices will arrive, and you see there the system administrator on top of his firewall. He's just looking down. Everything is safe. No zombies are entering the compartments. Everything is under control. That's maybe the situation like we think it is in IoT, but the reality is almost this. With the strong growth rate of the Internet of Things from, let's say, 30 billion devices up to 70, 80, 100 billion devices the next 5 years, the situation changes completely. So we have a security problem in IoT, so there will be a lot of zombies out there. And we are not able to manage the situation if we only put the firewalls higher on top. And even for many companies, it will be not possible to go, for example, for Industry 4.0, because the economic investments on maintaining the firewalls are too high. And by that, we were thinking in the CISEMA project together with the Calfas machinery company, how can they step securely into the Internet of Things for their machining applications. So the main objective of this project was that we can provide them for the case of retrofitting a solution where they easily can onboard on a retrofitting solution, where they have a solution which provides them cybersecurity during the life cycle of this sensoring network. Even we wanted to show how this can be deployed in a secure way. And as well, we have several objectives regarding the technical key features, for example, turning some parts of the system more decentralized to make it more resilient against attacks, and even to show with a small and medium enterprise machinery company that they can be enabled to turn into the Industry 4.0. So this was the main idea of the CISEMA project. The whole project was over 12 months, so there have been several milestones, like, as you know, in a rather agile way, like definition, what are the user stories in behind, always in perspective of Calfas, what do they want to achieve with retrofitting. For them, it's about having a multi-machine monitor for their customers, so that customers can supervise machines, multi-machines in a in a shop floor chain, and can do this by mobile devices. This was the main idea. And as retrofitting, doing this without integration of complex PLCs and stuff like that, just to get the KPIs which are necessary in terms of packaging machines for shop floor managers. So, and then we had different milestones going from prototype over the modeling of the different elements of the system. In general, what is the basic idea? The basic idea is that you can just take out of the box retrofitting network with different sensors. You can attach it to the machines. There's a connectivity module as well, and a module where you can get some or gather some certain machine data directly from the bus system. And we have a whole network then on top where you can maintain the sensors securely on a decentralized level, and where we can, for example, distribute all this kind of firmware and patch management systems to the retrofitting sensoring networks, and we get the data as well on a secure level, on a trusted level. Because we are short in time, just let me explain you some key features which are important, and even like for CalFAS, I'm for sure they didn't understand it until today. What is the complexity in behind of the IT system we have built up? Because the complexity is something like the IT people need to manage, and the machinery company needs to manage the complexity of their production process. But for example, building this kind of systems from a centralized level to a decentralized level requires to include some new technologies like a decentralized file management and distribution via IPFS. And as well, we have integrated blockchain to verify some certain trusted elements in a blockchain with smart contracts. For example, what kind of sensor assets are rolled out on this retrofitting networks, which is managed by a private blockchain in the Alastra network. Overall, everything rather complex, has a high complexity, but for the machinery company, at the end, it's just a package of sensors which have arrived, and a common gateway they have done in a common engineering where we can connect this sensor networks to their own bus system. And for them, it looks rather easy at the end from the user experience. Some several stuff. We did a live demonstration, and this is really installed in several manufacturing units now. There's a sensor kit where you have different sensors. Measurement is, for example, vibration, or we measure some certain production steps. The sensors can be attached as a retrofitting solution to the machine on specific places and even to specific buses. And this can be done easily by the machine manufacturer really on an easy level, on an easy way. And then there's a completely almost automized procedure in behind to set up and bootstrap the whole system from an IT perspective, and to bring this to life in forms of connectivity and security in behind to get the result that the company has. For example, this is a view of their mobile dashboard, to have now KPIs from the machines available on a mobile dashboard. Like the question, like what is the status of the machine, how many production cycles have been done on the machine, and stuff like that. As always, the interface looks almost simple and simple to use, and this is good for the customer. But of course, there's a lot of complexity in behind to bring IoT in industries securely to life and keep it even securely maintained during the life cycle. For example, this is a screenshot of the firmware update distribution system in behind. So there's a completely tool for them to do the remote configuration, automated for the sensor networks, to see the state of the sensors in terms as well for cybersecurity, and to decide, for example, if they need to apply patches or updates to certain elements of the network if it's necessary from a cybersecurity perspective. And I'm almost at the end of my presentation. So this is what we have done, and I'm rather lucky that even our customer we had there with CalFAS in the project, for them it was really the first step into Industry 4.0. And I mean, they have a really, like in small and medium-sized machinery, they have a really hands-on approach because they are a machine builder. It's something like they know very well what they are doing on the machine side. But to be honest, they have really almost no clue how to bring this into Industry 4.0, into smart production. And you know that this kind of companies, they really need the help and the assistance of experts and companies from the sensor or from the IoT side. So by that, the main idea of IoT for industries was to bring together both parts, players from both sides, and then enable them to deploy a common project. And I think this was rather successful. It's so successful that Kalfas even takes now the results into their own product management. So as they have built in the past machines, they are now building a digital product solution on top of the machine as a direct outcome of this project. And I think this is a great success and a learning story for them as well. So by that, thank you very much for listening, and I'm looking forward later on the Q&A.
Many thanks, Mr. Ross, for this entertaining contribution that even included zombies. We are now eager to hear Kris Putrins. He's Business Development Manager at IniVation in Switzerland. IniVation creates neuromorphic vision systems, and Mr. Putrins will talk about the benefits of neuromorphic vision in industrial applications. Please, Mr. Putrins.
Hi, everyone. I'm going to turn on my webcam as well. All right, there we go. All right. So first of all, of course, thank you for the chance to speak here today. I'm coming from perhaps a little bit of a different perspective. So the company itself, IniVation, we are the original developers of event-based vision. And event-based vision means we don't do things necessarily as the standard vision sensor, but we do it in a way that we only capture the pixels that have changed their lighting intensity. So, for example, if you have a view of a room and nothing moves in there, then our cameras and our sensors don't capture anything, so it's just blank. And once anything moves in the room, we only capture those pixels that have changed their lighting intensity. Either they've become lighter or darker, means that there's been movement. And by doing that, we're able to achieve really, really, really high speeds by keeping the data rates very, very low. So by using that technology, we started to see where can it be applicable in the industry. So we, of course, come from a very R&D side. So the company itself is a spin-off from ETH Zurich and University of Zurich. But we've branched out now to a couple of industries. And of course, industrial applications and industrial automation is very important for us. So by speaking together with our research partners and our business partners and our clients, the first ones that had tried out event-based sensors, we found out a couple of applications, not only in industrial automation for manufacturing, but also in high-speed rail infrastructure scanning and inspection of production, weld seam inspection, robot guidance, sealant application guidance, soldering quality control, and a whole bunch of others that are maybe not more for automation, but more for tracking and counting of people or things in high speeds and maybe different or difficult environments. And we always wanted to find out what benefits could our neuromorphic technology offer to those markets and to those use cases. And what we found out that essentially, if you look at the core of the problem, most of the things are fixed already, but they are fixed by using conventional technology, which in most cases, or specifically in these use cases, is maybe not the best solution because of the extremely high data rates and because you have to use custom-made CMOS sensors to achieve the results that are needed. Hence, sometimes if you take sealant application guidance, where it's the vision system is guiding a robotic arm in automotive manufacturing, for example, the vision system in the end can cost 2 to 3 times the price of the robotic arm itself. That's the reason because of the extremely expensive sensor itself. Now we are using our sensors, event-based sensors, and they are mass producible using standard CMOS technology. So in the end, we're not only achieving the same speed. We're doing it at much lower cost with much lower data rates. And there comes in our dynamic vision platform, which is essentially what we've developed so far over the years, which is of course the sensor itself, the software around it. It's our own data framework. I'll go back a little bit. So it's the sensor. It can either be embedded or with a PC. It does all of the things mentioned before. One of the added benefits is an extremely high dynamic range. We're operating at above 120 decibels. So for some industrial applications, that might come in very handy. And in general, we're looking at very high response times at about 100 microseconds or below 100 microseconds. And we're looking at full scan of the laser, for example, at 5 kilohertz, with the difference being that we're doing it at full resolution, which in our case is 640 by 480. And the total system latency that we have currently for our industrial camera, that's combining a laser with our dynamic vision sensor, is about 7 milliseconds system end to end. So that includes not only the laser profiling and the extraction, but actually a USB connection there as well. So if it was on an embedded system, as a next step, it's probably going to be at about 2.5 to 3 milliseconds tops. So we're able to achieve pretty much the top results in the industry that you can get by keeping the same accuracy, which is within 0.1% of the full scan range. And as I mentioned before, the biggest difference is that this is a completely new way of looking into computer vision and industrial computer vision. And we are, of course, still in a startup mode, kind of, but we are revolutionaries as well, in a way that if you want to work with event-based vision, you of course have to develop new event-based vision algorithms that work with this sensor. And there we're working together with industrial partners, not only camera manufacturers, but the end clients as well, that will actually use this thing to then build cars and build electronics. And our product, the evaluation kit that we've been working on now for approximately a year, it's coming out now. So we're saying it's available Q3 2020, so that's September, and it's been released officially by us. Of course, at the current stage, it's only a development kit, but it's meant to be as a proof of technology, proof of core technology, that it does what we say it does. And the next step probably for us is to really go into the business of it and work together with an industrial camera company that can get this thing certified and then use its sales network to really get it into the industrial clients. And we, of course, are more highly skilled in sensor development and software algorithms than actually having industrial cameras. But this is the direction that we're going in, and essentially that's what we've chosen our goal to be, is to have event-based vision in industrial applications, and not only in very strictly R&D spaces, but to actually have event-based sensors in our manufacturing around Europe. And I think we're getting closer and closer. We are already working with a lot of IoT projects. We have very recently released large news that we are doing neuromorphic eye tracking for virtual reality headsets. So that's a very different venue that we're exploring, but industrial vision is still one of the big focuses of the company, and we think that core technology like ours could actually help industrial applications surely. I think that is it of the presentation. Yes, so thank you for your attention, and of course I'll be available for any questions, or you could contact us if you have any interest in potential cooperation.
Thank you, Mr. Putrins, for your interesting presentation. We come now to Knut Aasmundtveit. He is the new program director of the Erasmus Mundus Master in Smart System Integrated Solutions at the University of Southeastern Norway. Knut, it's your stage.
Yeah. So thank you for the introduction. Can you see my slide now?
Yes, we can.
Very good. So thank you very much for the presentation, the introduction. My name is Knut Aasmundtveit. I'm a professor at the University of Southeastern Norway, and I'm happy to have the opportunity to present to this EPoSS annual forum, joint master degree, which heads towards educating the engineers for the smart systems industry. This is a cooperation between 3 European universities in Norway, Finland, and Hungary. And the title of the master degree is Smart Systems Integrated Solutions. This is a master degree where the cohort of students move to between the 3 institutions. So the first semester takes place at Aalto University, Helsinki in Finland. Second semester is at the University of Southeastern Norway, in Vestfold, which is by the Oslo Fjord, south of Oslo. And the third semester is at Budapest University of Technology and Economics in Hungary. And then the students go on to their master projects, and that can take place at any of these 3 institutions or at an external institution, which may, for instance, mean a company, where we particularly invite the EPoSS members to propose master projects relevant for the smart systems industry. The program as such is new now, with the first admission of students coming into in autumn 2021. But we build on a history since 2013 on the joint master degree in smart systems integration. This was headed by or coordinated by Hereford University in Edinburgh, Scotland, who unfortunately had to or could not take part in a new program because of Brexit. But we are happy to have Aalto University in Finland to take up the role here. We also do have associated partners in the program, and we are very happy to have EPoSS as one of the core associated partners. And EPoSS has been that since the very start from 2013. We also have relevant industry clusters and research organizations in the 3 countries, Norway, Hungary, and Finland, as associated members, together with our previous partner, Hereford University, and universities in Taiwan and Russia. And we also have 14 European companies as associated partners. So what is the study about? What do we teach the students in order to prepare them for the smart systems industry? Smart systems is a broad field, as this very annual forum here clearly shows. So the focus of the studies is both on microtechnology for sensors and actuators, and microelectronics for the signal processing. And we have a strong focus on the integration, which in our terms means both the integration of functionality in terms of combining the sensors and actuator part with electronics. This is mainly the Hungarian partner, which gives this part of the syllabus. But we also mean the physical integration in terms of assembly and packaging, which is introduced already in the first semester in our study. And we want to have the complete chain, both with this design, fabrication, and characterization in this study model. We use the core competence from each university to build a stronger program than any of us could do by ourselves. And in this way, we hope and we believe that we can serve the European smart system industry in the very best way. A few things I want to highlight on during the study. We have instances with winter school and summer school, and already before the first semester, a preparatory camp. And in this, we also include workshop with industry relevant problems. And we do have between the second and third semester, we have an industry internship where we very much want the students to be placed in companies like yours. One thing which is special about this type of study is that since the students move between three countries, three universities, they get very strong cultural competence in the way that they learn how to work in three different European countries, and they are then very well prepared for working in an international environment. So the actual breakdown of the subjects, I'm not going to go through this in full detail, but the students go through a selected set of courses where we have tailored the program, so it shall be so the section. The courses they get at the different universities should match, so the total education is as good as possible. So we have obtained this Erasmus Mundus label from the European Union. That's an application we sent this spring. It's a very tough competition to get this, and when we got this from the European Union, means that we have one of the highest quality labels we can have from EU in terms of the education itself. And this is particular for this program with 3 or more universities from 3 or more different countries. With that, we also get student scholarships, which again gives us then very good students indeed. Also, there's a profile of the scholarships with towards different regions of the world. So we have a very high number of nationalities in the program, which also contributes to this high cultural competence of the students. Our first graduates in the previous program graduated in 2015, and we see that they indeed scatter around in a high number of different countries. We have registered more than 12 different countries where they are employed, most of them in Europe. So again, demonstrating that they have this capability of working in different environments. And what type of work they have come into span from different startups to big companies, and even some starting their own companies like Sophia shown here. Many start with PhDs, and the first ones are now graduating since we have 5 years since the first master graduate. And that means that we can now offer not only master graduate but also PhD graduates coming from our study. So what do you wish from you as smart system companies and stakeholders? We wish you to take part in the industrial advisory board. We wish you to offer these internships during summer for the students, and we wish you to offer master project topics. And indeed, if you can also sponsor scholarships for extending the number of students and also beyond the time of EU funding. This is something we would highly appreciate. And these questions we are including in a survey or a poll, which you will get in a minute, and we ask for your responses here. And of course, we want you to offer jobs to our graduates. And with that, I'm thanking you for the attention from our consortium. And you show here some of the key persons involved in the actual program. That's all from me. So I guess I leave for the moderator to let the audience do the poll here, or the survey.
In the chat, you can see the link to the survey, and we would kindly ask you to take part in it. So thank you very much, Mr. Aasmundtveit. It's again time for some questions, and I would like to ask Ms. Neuy to take over the panel and ask to all speakers of the session, please turn on your mic and your cameras.
So thank you very much to all the speakers in this session. I'm looking forward to this question and answer session now. And we've already received the first question, which was partly already addressed, but I think, Knut, maybe you can answer this anyway. So the question is, how can a company apply to be a partner in the program? Are there any costs associated with this? And what would be the company's obligations?
Thanks for the questions. If you wish to join as associate partner, I guess the easiest thing is to contact me. I'm, by the way, the overall coordinator of the master. I didn't say that, and I guess my email is distributed in the with the meeting. There are no direct obligations, but this is highly linked to the expectations, as I just sorted out, either to join the industrial advisory board or to offer internships or master projects. Also, what a number of the associated partners, which are more locally based in Norway, Finland, and Hungary, does is to also provide company visits. So we take the students to the actual companies or guest lecturers. So these are different tasks. So there's no specific task of obligation. This will be according to the different companies' needs or wishes. I'm happy to
Okay, thank you, Knut. Mirko Ross, could you please also start your camera so that everyone is able to see you on our panel, which is a virtual panel today. So maybe I come to a question to Alessandro, who I know from some projects in the past. So the good news for me was that human plays a role in manufacturing according to your findings. The interesting thing would be also how do you transfer this knowledge that you presented in your presentation to the industry, especially to SME? You mentioned a project with your members. But how do you organize this transfer of information so that the industry will be enabled to take, to use all these offers?
Yeah, we have in AFIL two different tools that we use, and now everything has become virtual. But we have been able to continue to work with them. The first one is the strategic communities. There are the projects that are supported and developed by the members that participate to develop what are the needs, technological needs for some on some topic. For example, we have a very interesting community for sustainable food manufacturing, where the members that are typically food factories are interested in going through technologies that can help them to improve sustainable food security, and especially conservation. So packaging applications, materials, and all these kind of things. Another important tool is the innovation labs. Innovation labs are initiatives that are seminars, very short, no more than 1 hour and a half, are online seminars. And curiously, we have developed them before the COVID, and has become a very popular event for our members during the COVID period. And during these innovation labs, the universities and research centers, especially that are in AFIL, make lessons or develop several topics that are important for the members. Goes from vision systems. It depends on what are the basic needs that are expressed by the members. So with these tools, we make a lot of cluster. So we develop and we share knowledge, and then we have the projects. With the projects, there are also that one that I've showed is a private project, but also finance projects, where AFIL is often a member of for the diffusion. So we help them diffusing the knowledge they have developed.
Okay, thank you, Alessandro. Yeah, there was another question to Alessandro. Has it been researched the psychological impact of humans obeying smart machines or systems? Have you any insights into this question?
Yeah, this is one of the things that we are in that project I was mentioning before. This is one of the things that we are thinking about. For example, this morning when I was waiting, I had a discussion in the mail, a chat discussion with the chief engineers of this company, where we have designed the new interfaces that will be for supporting augmented reality and the interaction with the machine during the building of the machine. So, for example, one of the things that we want to understand is which is the acceptance of the worker, because if we give them all the informations that are helping him in assembling the machine, it's good. But which will be we are wondering which are the best position of the buttons and or the screens on the windows. But when we will go through augmented reality, yeah, we are wondering how they will accept. So we were deciding to have an acceptance test before going in production with that. We are very interesting things there. So, how the workers accept this. But we don't have any at the moment. We have involved in this project the University of Trento for supporting us in these topics. But yeah, this part is now under development.
Okay, thank you, Alessandro. Question to Mirko Ross. This project as part of IoT for Industry, you mentioned, so you said the focus was on security, cybersecurity topics. So after implementation of the demonstrator in the company, what you see are the main challenges, or what was the challenge at all for the company? Do you find them in a good position with respect to cybersecurity? Or was it groundwork for you?
Yeah, to be honest, I mean, for us, this was really a best case company, because it was a company who was a long time thinking about stepping into smart industry, but never did it. Like, because there was not, let's say, too much pressure from outside of doing this. but there had been a lot of ideas of what they can do. Now with this project, we have given them the first idea of what is all possible, like if we turn the data layers on it, and even we had the possibility to lower the barriers. Like, for example, if we take cybersecurity is a typical barrier. I mean, this is also a lame excuse often for doing nothing. Like, especially in the industry where, let's say, like where they have a traditional business and they are not even like too much forced towards changing the business model. So what we've seen is, okay, if you provide them a solution where they can get easily an impression of that there are, let's say, a lot of experts in behind who put a lot of brain into how to make it secure and give them these tools, we lower the barrier of stepping into the smart industries. And yes, cybersecurity is to me always more a topic like that people are looking for. I mean, they're taking the topic and even they're taking the topic to build higher barriers of not going into smart production. To me, the most impressive feedback of the customer was, oh, it works all very well, so we are rather satisfied. But look, even now with the project, we are thinking about new business models. Like we have a lot of times before we have talked about, can we turn from a sell machine business to a pay machine time business? And this had been always discussed, let's say endless discussed. That to do this, you need smart machines, because otherwise you can't step into this business model. So you're discussing something for the future, but you're not ready for doing the first steps. So with this project, we did the first steps. And now they can discuss about how to make new business models. And now there's the acceptance in the company. And now they get the feedback from the customers much more qualified what it means to turn from a selling machine to a selling uptime and production time. And that's to me the real success of this project. So not only having a smart product and showing that it works, even like turning the mindset of everybody in the industry there.
Yeah, and I think those kind of best cases are very important, and we have to spread them to the world so that everyone can learn from it and see that the barriers can be overcome. So thank you. I also have a question to Kris Putrins. You mentioned the chip and the hardware that you're producing in mass production already. And I was wondering how you see the relation between the hardware as such, the chip, and the software. So I understand with all the work that you're going to do with the algorithms that there will be a focus also on the software and the programming. How do you see the balance between the hardware development and the software development?
Yeah, that's a very good question. I think it's a lot depends on the strategic direction which we would want to take. So of course, initially we focused on hardware development. So we had to start with the core technology. We had to come up with a chip. Now, to get it mass producible, of course, we can't do it ourselves. So we got in business with a large industrial partner that's able to produce them. Of course, when you produce them in very, very large quantities, the price per chip and the margin per chip is extremely low. So it only makes business sense once you're able to put that in a mobile phone. Essentially, that's what we're talking about nowadays. And the big margin is if you can build applications around the chip, if you can actually build algorithms that do the things that are necessary to get the most out of the chip. And that's what we are focusing mostly on now. So in the company, we of course have a hardware department with chip designers, but most of the focus now, and I think bulk of the company actually is working on software development to actually have these applications that do use the chip. And that's where we see our business model going forward, is probably focusing on the applications and the use cases and finding those niches where we can provide the solution instead of just a naked chip, because in the end it's still made by a couple of companies like Sony and Samsung in the world, and a startup can probably make the most margin by developing solutions.
Okay, thanks a lot. we're heading towards the end of our question and answer session. I still have a question for Knut again. So we closed the cycle more or less of the questions. So to your programs, it's in fact 2 questions. So will Edge AI courses be part of the program in the future as well? This is a more technical content question. And I was also wondering whether COVID-19 encouraged you also to offer virtual or online courses, if this is a model which you will follow in the next weeks or months. And whether with looking at the time, if you try to be short with your answer, that would be great. Thanks a lot. And yeah, please.
Yeah, thank you. And I shall be short. For the future development of the curriculum, that's where I really want to invite this industrial advisory board, which we are now want to establish, and also want members from EPoSS to join. So that's a particular topic to discuss there. So it is possible, but I will let that be up to the IAP. For the COVID-19 and virtual teaching, we have all universities around the globe have now done quite a bit of virtual teaching during this last half year. So we have for sure gained the experience in that, and we are now, at least here in Norway, we are in the process where we are partly doing virtual teaching and partly on campus, and this is now different in the different countries, how much it have the one proportion or the other. So we will evaluate how this is going and what we will bring forth in a normalized situation, which we hope will come in not too long a time. I don't have the answer yet, but it's something we are bringing into our evaluation further on.
Okay, so almost in time. Thanks a lot to all the speakers. Again, it was a great pleasure to have this session for you, and I'm looking forward to meeting you in person someday, and good luck to all your work in the next future. Thank you.
Hope so.
Thank you very much.
Christine. Thank you very much.
Bye-bye.
Bye-bye.
Also, thank you from our side for this insightful Q&A panel. Thank you for your questions from the audience, and I think we have earned a break now, and we see each other again at 15:15.